Alright, so today we're going to be looking at 12.4 where we cover the counting principle. If at any point in these notes I'm going too fast, feel free to stop and back it up if you need to, so that way you can get all the information that you need. It would be smart of you to go ahead and pause after each example to make sure that you can find the answer by yourself rather than just copying down everything that these notes tell you. So let's get into the counting principle. The first thing we're going to talk about is factorials. So for a couple of your classes, I did tell you about factorials, and the others, I did not. So if you look up on the whiteboard, on the right side of the whiteboard, there is directions to find the factorial button on your calculator. Okay, and the factorial is simply just this exclamation point. That's what we're calling a factorial in math. Okay, so if we say some number factorial, what that means is we're going to take that number and multiply it by all the numbers that are smaller than it, all the way down to 1. So the first example that they give us is 5 factorial. Okay, so to find 5 factorial, you can either just punch in 5 and then this exclamation point, or you could do 5 times 4 times 3 times 2 times 1. Either way, you should end up with 120. Okay, so factorials are simply just multiplying by each number that is smaller than the one we started with. You'll see that when we get to bigger numbers, it is definitely going to be a shortcut if you know where that factorial button is. So let's take a look at 3 factorial. So remember, for factorials, we're just multiplying by each number that is smaller than the one we started with. In this case, 3 factorial is just going to simply be 3 times 2 times 1, which will give you 6. Now we take a look at 6 factorial. 6 factorial is once again just going to be 6 times 5 times 4 times 3 times 2 times 1. You can either punch all that in or you just hit 6 factorial to find that your answer is 720. Now remember when I was explaining factorials, I said that we always stop at the number 1. We don't ever go lower than it. So if we had 1 factorial, well, that's just going to be 1. There's nothing to multiply it by. Now we take a look at 4 factorial, and 4 factorial ends up being 4, 3, 2, 1, which ends up being 24. Now this one here, 0 factorial, is the only special case. 0 factorial kind of breaks the rules. So what 0 factorial ends up being is just 1. Okay? Because we can't multiply by any numbers that are smaller than 0, because they would all be negatives, so we just leave it as 1. And lastly, we have 13 factorial. So this would be the one where it would be smart for you to be able to find that factorial button on your calculator, because nobody wants to sit there and take the time to do 13 times 12 times 11 times 10, blah, 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 and get all the way down to their answer. Okay? So if you're able to plug in 13 factorial, you'll find that it's actually 6,227,020,800. So let's move on to the counting principle. For the counting principle, basically what it is if an action can be performed in X ways, and for each of those ways, another action can be performed in Y ways, then the two actions can be performed in X times Y ways. So basically all we're going to be doing here is we're just going to be multiplying the number of options we have for each thing together. So let's first take a look here at this example. It says you are invited to a sweater party and a hat party. There are 4 hats and 2 sweaters to pick from. How many wardrobe combinations are there to pick from? So according to our counting principle, all we have to do is take the number of ways that we can select a hat times the number of ways that we can select a sweater. So we had 4 hats and we had 2 sweaters. So all you simply do is take 4 times 2 and we find that we have 8 wardrobe combinations. Next, how many different ways can this class line up at the door? So let's say, for example, here we have a total of 25 students. So when you do the counting principle, you'll notice that for the first spot, you have 25 different students to pick from. Okay? Then after that, you would have 24 for the second spot. And then you'd have 23 for the third spot, and so on and so forth. And so what you'll see is that you're really just going to be multiplying 25 times 24 times 23 all the way down to 1. Well, if we remember from the first page, that's just simply going to be 25 factorial. And you'll see that if you plug in 25 factorial into your calculator, it's going to give you some weird answer. So that's why I'm okay with us just leaving big numbers like that as the factorial. Okay, so that one would be fine to leave as 25 factorial. Next, we'll use our accounting principle to look at license plates. So how many license plates can be made with 3 letters followed by 3 numbers? So first we know that there's 26 letters in the alphabet. So for these first 3 spots that are all letters, we know we have 26 options for each. Now, for the numbers, a lot of people will mess this up because for the numbers, remember you have to include 0. So we're really counting all the numbers from 0 to 9. So if we count all the numbers from 0 to 9, there's actually 10 different options. So for each one of these last 3 spots, we have 10 choices. Now what our multiplication counting principle tells us is that we are simply just going to take 26 times 26 times 26 times 10 times 10 times 10. And that will tell us the amount of ways that we can create a license plate. So when you punch that all in your calculator, you should find that we have 17,576,000 different license plates. Now the next question is, what if the letters and numbers can't be repeated? Well, we're still going to start with 26 letters for that first spot. However, after that first spot, we can't reuse the first letter that we chose. So now there's only 25 letters to pick from. And then after we use that letter, now there's only 24 letters to pick from. And that will cover all 3 of our letters. But then we have to look at the numbers because the numbers can't be repeated either. So for the numbers, we have 10 options for the first spot, followed by 9 options because we can't repeat, followed by 8 options because we can't repeat that one either. And so when you punch this into your calculator, 26 times 25 times 24 times 10 times 9 times 8, you'll see that we now only have 11,232,000 different license plates. So by not repeating the letters or numbers, we end up losing a little over 6 million different license plate combinations. Next, in how many different ways can you answer 10 multiple choice questions if each question has 5 choices? So basically we have 10 different questions, all that have 5 different answers apiece. So to solve this one, we have 5 choices for the first question, 5 choices for the second, 5 choices for the third, for the fourth, for the fifth. So all 10 questions have 5 options. So we are simply just going to take 5 times 5 times 5 times 5 all 10 times, or as a shortcut, we should know that that really is just 5 to the 10th power. Okay, so when you take 5 to the 10th power, you'll find out that you really have 9,765,625 different ways to answer the questions. All right, so now for the telephone example. It says that telephone numbers in the US and Canada have 10 digits as follows. So we have a 3-digit area code number, which the first digit is not 0 or 1, and the second digit must be 0 or 1. So if we look at this one specifically, so we're looking just up at the top here, if the first digit cannot be 0 or 1, we only have the numbers 2 through 9. So that only leaves us 8 options. Okay. Now it says the second number must be 0 or 1. Well, if it has to be 0 or 1, that only gives us 2 options. And then lastly, the third number, it doesn't say anything that we can't have for the third number. So for the third number, we just assume that we can use all numbers from 0 to 9, which we have 10 options from. Okay, next, we have the 3-digit exchange number. So it says the first and second digits are not 0 or 1. So just like before, if we can't use 0 or 1, we only have 8 choices for both the first and the second digit. Now for the third digit, it doesn't give us any restrictions once again. So we can go ahead and use all numbers from 0 to 9. And lastly, we have the 4-digit line number. The only restriction here is that it can't all be zeros. So basically, we have 10 options for every single one of these, except for one has to be 9, just in case the other ones were all zeros already, because we can't have 0 in all 4 numbers. So now, how many possible area codes are there? So remember, the area codes are these first numbers that we chose up here. So all we have to do is take 8 times 2 times 10, which gives us a grand total of 160. Then the next one says the area code for Chicago is 312. Within this area code, how many exchange numbers are possible? So exchange numbers are the second line here. Okay, so to find our number of exchange numbers, we do 8 times 8 times 10 for a grand total of 640. All right, now we have one of the exchange numbers for Chicago is 472. Within this exchange, how many line numbers are possible? Well, line numbers, remember, are the 4-digit, that just not all 4 of them can be 0. So what that means for us is we have 10 options for the first, 10 options for the second, 10 options for the third, but only 9 for the fourth to prevent all of them from being 0. And so when we multiply this together, we get 9,000. And for the last example on your notes, it says how many 7-digit phone numbers are possible in the 312 area code? Well, all we have to do is just exclude the area code and look at the total combinations with our exchange numbers and our line numbers. Okay? So we just take our exchange numbers from before, which was 8 times 10. Notice they're all in green. And then we're going to multiply it by our line numbers, which were in blue. So at 10 times 10 times 10 times 9. And so really all we have to do is take our two answers. So we can just take 640 times 9,000, and we'll find out that we actually have 5,760,000 different phone numbers we can create within the 312 area code. All right, so I know these examples that I'm about to go over aren't on your note page, and it's totally fine that they're not. You don't necessarily have to copy them down, but it'd be smart for you to listen to them because it's more like your homework questions. So, a restaurant offers 4 sizes of pizza, 2 types of crust, and 8 toppings. How many possible combinations of pizza are there with 2 toppings? So, what we need to do is we need to take the 4 pizza sizes, 2 types of crust, and 8 toppings. Okay? And actually, I'm going to change this real quick just because of how it's already written. We're going to say you only get 1 topping, okay? So change that to a 1. So what that means for us is we just take 4 times 8 times 2, and when you multiply that all together, there's 64 different pizzas. All right, next one. You go to Best Buy to purchase a new television. You have the following choices: LCD or plasma, screen size of 27 inches, 32 inches, 36 inches, 41 inches, 51 inches, or 63 inches. And then you get to pick the manufacturer of Sony, Vizio, or Philips. So just break it down piece by piece. To start with, we can choose LCD or plasma. So we have 2 options. Then for screen sizes, we have 6 total options. And then for the manufacturer, we have 3 different options. So how many different televisions does the store have to offer? Well, we multiply those 3 together, and there's 36 different TVs. A lock has 4 dials. On each dial, the digits are 0 to 9. How many possible combinations are there if the numbers can be repeated? So what if they can't be? So if they can be repeated, we have 10 options for each spot. So we're simply just going to take 10 times 10 times 10 times 10. Okay? Which will give you 10,000. And if they're not repeated, you just have to take 1 away each time. 10 times 9 times 8 times 7, which will give you 5,040. And that is it for the notes for today.